Welcome to section 4.6, fitting a line to data. So one thing you need to know is just the term a scatter plot, which is just a graph with just a lot of individual dots that are scattered about. That sort of can show you just the overall picture of the data you're looking at. One nice thing with that is it allows you to start seeing trends in the data. So for example, this far left scatter plot here, the data is all generally going upwards from left to right. You could, what this is called in the math world is it has a positive correlation. So in other words, as your x value increases, your y value increases. The next one, or that middle graph, has a negative correlation because it's going down as you read it from left to right. So in other words, as your x increases, your y decreases. So they go in opposite directions. Negative correlation. That third graph on the right side, that is all over the place and doesn't really have any trends. So you can't actually draw a line of best fit for it. So you just say that that has no correlation for that one. So let's go ahead and describe the correlation of some other data. Well, if we are comparing on this first graph, the number of hours you spend studying to the test scores that you receive, there's a positive correlation. The more time you spend studying, the better your test score. We could also have negative correlation. That would come from the number of hours you watch TV in a day or a week correlates with a negative or has a negative correlation with your test scores. If you want to draw conclusions, maybe you could, if you want to increase test scores, spend more time studying or less time watching TV. That's what these graphs would be suggesting. And I would also be remiss to say that in every stats class, one of the main lessons you will try to get out of it is the term, or is the understanding of the phrase that correlation does not mean causation. Just because two things are correlated does not mean that one thing causes the other. For example, the hours that you spend watching TV, just because you decrease the amount of time you watch TV doesn't necessarily mean that you'll do better on your test because you might not have actually studied to do better on your test. Or for your test scores, just because you spent more time studying, you maybe weren't studying what was actually on this test and therefore didn't actually do better. So just because they can be related and can be shown on a graph to be related does not mean that one thing causes the other. Another example of this would be that the number of drowning deaths in a year has a really strong positive correlation with the amount of ice cream sold. Now, eating ice cream is not going to cause you to drown. But if you think about it, you don't go swimming outside unless it's warm, unless it's the summer. And you're generally not eating ice cream unless it's also warm and summery outside. So those things both go up at the same time, but they're not actually related to each other. They're both going up because it's summer. So that's just another way that you can try to understand this. So something you might be asked to do in this chapter is use the data to make a scatter plot. And all that means is that you just have to graph the data. So let's have the x-axis be the length, and then the speed will be the y-axis. So our length goes from 19 up to almost 40. So let's just go up by fives. So in this case, 5, 10, 15, 20, 25, 30, 35, 40. And our speed goes from, our lowest is 47, our highest is 148. So let's go by 25s. So 25, 50, 75, 100, 125, 150. And now we can just go and plot our points. So at 37, oh, and actually I'm just going to 15, 25. I need to label these a little bit more so that I actually remember where numbers are. Okay, so now I can go and plot these. So at 37.8, we're going to be up at about 148. At 19.2, we're going to be up at about 47. So about there. At 21.3, just slightly to the right, we're going to be up at 88. At 26.2, we'll be up at 131. And at 26.8, we'll be up at 98. Well, now if I were to just look at these and eyeball it and figure out, okay, if I were to sort of try to describe the correlation, or I could even try to draw a line. This line might be about a good average for all those points, and it's going up and to the right. So if I wanted to talk about the correlation here, I could say it still has a positive correlation. And this line is actually called a line of best fit. And what a line of best fit says is we're going to try to find a line that sort of goes right down the middle of all of our data points. About half of our points will be above the line, about half will be below the line, and hopefully that line can be used to try to predict where other points will fall. And it will maybe even help us better understand the data that we have. So now let's go ahead and make a scatter plot and find the equation of the line of best fit. And this equation is actually from a word problem that I'll just read out quickly for you. So this table shows the number of active red-cockaded woodpecker clusters in a part of the DeSoto National Forest in Mississippi. Find an equation that models the number of active clusters as a function of the number of years since 1990. Well, that means we just need to plot all of this and then draw a line and figure out what's the equation of that line. So we'll start out, and so we're going to go, time 0 here is 1990. So 1, 2, so here's 92, 93, 94, 95, 96, 97, 98, 99, 2000. And we need our clusters of woodpeckers to go up to 51. So let's go up by 5s. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And 1, 2, 98 and 2000. Okay, now I've at least got it labeled so I can see what my points are that I'm graphing. So 92, we have 22 clusters of woodpeckers. So that means we're going to have about there. 93, we're up to 24. 94, we're up to 27. 95, we're still at about 27. 96, we are up to 34. 97, we are up to 40. 98, we are up to 42, so just slightly higher. Come on, that's supposed to be, there we go. 99, we're up to 45. And 2000, we're up to 51. So looking at this, there is definitely a really strong correlation here. So I'm just going to draw my best line of best fit. And now I just need to figure out what the slope is of that line. So I'm looking here, and it looks like we cross our y-axis at about 17. So it'd have a point at about 0, 17. And then I'd look at just what on here is maybe a good fit to just sort of try to balance out that line to make it a little bit straighter. So I'm thinking I might go with this point right here. So 2000. So that's going to be our 98, 42. So now I just need to go and figure out what, from these 2 points where I'm just sort of stretching this line between them, what is the equation of the line that goes through that? The nice thing is we have our y-intercept here. So now all we need is our slope, and we'll have slope-intercept form. So let's go ahead, and 98 is the same as 8 on this graph, and then 42. So let's go and take our 42 minus 17 over 8 minus 0, and that will give us a 25 over 8. So now the equation of our line, because we now have our slope, is y equals 25/8 x plus 17. And that's going to be our line of best fit for this one. And everyone's lines of best fits, especially if you're doing this by hand, will be different. So your line of best fit might not be what it says in the book, but as long as you're sort of close, it's fine. If you are way off, go ahead and shoot me an email, and I will try to help you out the best that I can. Otherwise, that's it for this section. So good luck, and let me know if you have any questions.